Pure, unpolluted water has always been available in abundant supply. It still is, but not always where you want it. Where water is needed, there is now a shortage of it. Indeed, throughout the world, we now seldom speak of water without adding the word crisis to it. As long as water is used only for drinking, nature can be relied on to provide pure water almost anywhere. Piping it to consumers is the first step to civilized life. But very little water is actually consumed by drinking. Most of it, indeed nearly all of it, is wasted by industry and, not least, in our own homes. We seldom realize the untold volumes of water going to waste in our houses. This is the situation today. Not only are we faced with a worldwide water shortage, our lakes and rivers are contaminated and have become a menace to life. Now let's consider one of the major sources of water wastage and contamination, the convention. Once a sanitary blessing, now the greatest single source of water waste and contamination. Here are 16 liters, that's 4 gallons, of water going to waste. It's been brought at great expense from a distant source, only to be wasted and contaminated. What happened to it? Well, here's a diagram of a dwelling and its sanitary installations. Toilet, a bathtub, a lavatory, and a kitchen sink. The waste from the lavatory, the bath and the sink may be termed grey water. It's harmless, practically speaking. Of, say, 200 litres and more of waste water, constituting the tailings of one person per day and discharged into the common sewers, about 1/2 consists of this grey water. But the other half, the discharge from the toilet, which we call black water, is the chief contaminator. It's the source of the waste and trouble experienced by most communities. It carries almost all the pathogenic bacteria and viruses and intestinal parasites. But that isn't all. It also carries the nutrient salts that inevitably pollute the receiving water bodies. To sum up, 1/2 of domestic water is wasted. This is the problem that has to be overcome. Of course, we know the source of the trouble, the conventional water closet. It not only wastes 1/2 of the domestic water, but being connected to a common waste pipe and sewer, it also contaminates the previously harmless grey water. Knowing the reasons, we can ask, how are we going to control contamination? How are we going to stop water wastage? And the answers? Keep the black water separate from the rest, and reduce the volume of water now wasted on the transport of human tailings. But that's easier said than done. No local authority, thinking along conventional lines, would contemplate the construction of 2 separate sewer systems, at least not yet. And we know of no method whereby the volume of water required to flush a water closet can be reduced to any appreciable extent. Now, fortunately, there is a way, the LilJendahl system. It saves water. It prevents pollution. For the moment, getting down to basics, the system achieves this by separation of the black water from the grey water and the use of air as a transport medium. By separating the black water from the rest, we control contamination. By using air as a transport medium, only 1 litre of water is required for each flushing. By this means alone, we obtain a 50% saving of domestic water. But by using air instead of water gravity flow, we not only control contamination and save water, we also gain other benefits, such as lower construction costs, independence of grade, lower maintenance costs, elimination of odors, and a higher standard of hygiene generally. Let's now briefly consider the layout of a LilJendahl Vacuum Sewer System. It includes a vacuum toilet with its unique outlet valve mechanism, which is connected by small diameter plastic piping to a collecting tank kept at half atmospheric pressure by a vacuum pump. Let's keep this diagram in mind while we describe the working of the vacuum toilet. It's best done by following the flushing cycle. We press the button and set the timer, which opens the outlet valve. The atmospheric air forms the waste into a liquid plug that is propelled by air pressure through the pipe. When the air valve is opened, a second timer operates to admit cleaning water to the bowl. 3 seconds have now passed. The first timer now closes the outlet valve, while the second timer keeps the water valve open until the bowl is filled to the desired level. The complete cycle has taken 7 seconds, and the outlet valve has kept open for 3 seconds. During that time, it has admitted 80 liters of air, but the water valve has admitted only 1 liter of water. I repeat, 1 liter. Now let's see how a vacuum toilet looks. And how it works. One common test to measure the flushing efficiency of a toilet bowl is to throw in a number of balls formed by toilet paper. Let's flush. Watch the plug flush upwards in the window of the pipe. Or let's try newsprint. And flush. Or a can of dog food. Or a banana. And sanitary napkins. And disposable diapers. And even cotton diapers. What happens with the rest that normally ends up in a toilet bowl when there are children around? The hard objects, toys, pencils, etc. What happens is that the elbow, connecting the outlet, curbs the admittance of hard objects when too large. Anything that passes the elbow will pass through the rest of the system. Anything that doesn't pass through the elbow will stay there and can be easily removed. And what could be more simple? The vacuum toilet is also self-ventilating. Look what's happening to the vapor. One final look at the toilet. We flush the disconnected toilet. Notice the water timer and how positively it closes the water valve. This valve cannot leak. It's also a check valve. There is no possibility of siphoning into the water supply. Now we'll measure the water. How much do we have? Almost a liter. Yes, 1 liter as against 12 liters for economy bowls. Now let's look at the vacuum toilet from the plumber's point of view. How does he maintain it? Well, to begin with, he removes 2 screws and gains access to the flushing mechanism. but he thinks it necessary to remove the whole works. All right, he loosens 4 more screws and disconnects the water supply. Now he can remove the whole mechanism and the outlet valve too, if needed. If for some reason he wants to remove the entire bowl, he removes 4 more screws and the bowl is replaced. What applies to toilets also applies to urinals, except that they're equipped for automatic discharge that can be... And note here that the largest pipe is only 2 inches, and the vacuum toilet connection 1.5 inches. The house connection is 2 inches for both black and grey water. A 2-inch black water main in the foreground will serve 700 persons. There's no need to slope vacuum sewer lines. The collecting tank is scaled on the basis of 8 litres. That is 2 gallons of black water per person per day. These are located at a treatment plant at Harold Roads in the Bahamas and designed to serve a public housing community of 175 houses and a school. In the same manner, the size of the vacuum pump is adapted to the population served. This 4-horsepower unit is adequate for 800 persons. The LilJendahl system is very flexible and can be accommodated to different methods of treatment and disposal. For example, it lends itself to isolated houses beyond the reach of common sewers. The black water is discharged into a collecting tank and removed periodically, while the grey water is discharged untreated or treated depending on local requirements. In small housing developments, the vacuum sewer discharges into a common collecting tank for subsequent disposal or treatment as required. In some localities, the kitchen sink waste is also discharged into the vacuum sewer to eliminate the possibility of organic pollution. Then the remaining grey water is either discharged untreated or reclaimed for reuse at minimum cost. Either way, the black water, with the liquid kitchen waste added, is about equal in volume to 1/4 of the domestic waste discharged into a gravity sewer. That's why it's the most economic sewage system there is. In locations with adequate treatment capacity, the black and grey waters may be discharged in the usual manner, that is, into a common gravity sewer. But by using LilJendahl vacuum toilets, we save some 40,000 litres or 10,000 gallons of water per person over a year. Therefore, the existing water supply can be used for twice the number of inhabitants. A small summer colony of 40 houses on the Swedish west coast is built on solid granite. Here, vacuum toilets were chosen partly to escape the costly blasting needed for gravity sewers. The vacuum sewers were laid independent of grade. At Bromstein, a suburb of Stockholm, a 6-story apartment house is provided with vacuum toilets. They discharge into the common sewer. At Harbour Mews in Nassau, 45 high-class garden apartments were equipped with a vacuum system in 1966. The black water is treated in a small chemical plant, and the harmless effluent discharged into storm sewers. And elsewhere, the LilJendahl vacuum system is used on a major scale. In public housing developments, apartment blocks, schools, office buildings, luxury hotels, and hospitals. This is Stakert, the pioneer installation where the LilJendahl vacuum sewage system has served to full satisfaction since 1959. And everywhere, the reason for using the LilJendahl Vacuum System is the same: to save water and put a stop to contamination, to protect the most valuable asset we have, pure water.